Okay. So now we proved all of these rules, which is really nice, but let's put them to use. Let's actually figure out how they're helpful. So one of the things that we do is we use them to simplify exponential expressions. So we take something that looks really complicated, and then we make it much simpler. So there are three things that we have here, okay? Three things that we have to worry about. The first one, we don't want any parentheses. So I'm giving you what you need to look for, and then afterwards, we're going to actually try some so you'll see it. So no parentheses. The second one is that you can only have one of each base. Okay. So we should clarify that. If we have a to the x, the a is called the base, and the x is the exponent. So you probably already knew that, but I just want to clarify for saying one of each base. Sometimes these lines just appear out of nowhere. Okay, and then the last thing when we simplify exponents, is that we don't want any negative exponents. So for example, if we wind up with a to the negative x in our answer, we want to make sure that we have 1 over a to the x. Okay, so let's just do a bunch of examples and we'll see how it works. Okay, we're going to start off relatively simple. I'm going to start off on the next page, but feel free to you want to keep referring back to this page here for those three rules. So suppose that we have a to the negative 2, b squared, and let's raise this to the 5th power. So if we do this, we know that we're multiplying inside of here. And when we multiply, we're allowed to distribute our exponent. So that's what we're going to do. We're going to distribute this exponent. So this becomes a to the negative 10, b to the positive 10. Okay, so we distributed the exponent. And because we have an exponent raised to an exponent when we're distributing the exponent by multiplying. So if we go back to here, we did our first thing. We got rid of parentheses, and that's how we get rid of parentheses. We distribute our exponents. And you can do this in this one you can't really do in a lot of different orders. You can do it in 2 different orders, but I recommend that you do it this way so that you never forget how to go through this, and you're very, very particular about getting rid of each of the things that you need to get rid of, that you go through it in that order. It's the most efficient. So in this problem, we could get rid of negative exponents first. So you see here, no negative exponents and no parentheses. We could have gotten rid of the negative exponents first. But in other cases, sometimes when you get rid of negative exponents first, you have to then get rid of them again, and you'll see that later. So first we got rid of the parentheses. Now if you notice, we're not done. So we have one of each base, meaning we only see one A and one B. So that's not a problem. We don't have to worry about that right now. But what we do have to worry about is the fact that we have an A to the negative 10. So I'm going to do this in 2 steps. But in the future, you're only going to see me do this in 1 step. So a to the negative 10 can be rewritten as 1 over a to the 10th. So this is 1 over a to the 10th times b to the 10th. And what you're going to see here is that when you multiply, all you did is you moved your a to the 10th to the denominator. We don't have to rewrite it every time. We can just say, okay, a to the 10th, this is a negative exponent, so to make it positive, we just move it into the denominator. So our next step here, so usually we're going to skip this step. We're not going to do this every time. But what we did here is we got rid of negative exponents. So you don't have to write these separate fractions. You can't just move it, okay? You can see here, this is like b to the 10th over 1. So 1 times b to the 10th is b to the 10th. A to the 10th times 1 is a to the 10th, okay? You should also note 1 over a to the negative x is equal to a to the positive x. Okay, in other words, if you have 1 over a to the negative 5th, you can move that into a numerator. So if it's in the denominator and it's negative, move it to a numerator. Okay, the reason for this is 1 over a to the x, right? But we don't like fractions within fractions. So we can get rid of that. And the way that we get rid of it is we multiply by the reciprocal. Because if we multiply the denominator by the reciprocal, the a to the x cancels. But what we do to the bottom, we have to do to the top. So we have to multiply the top by the reciprocal also. And 1 times a to the x is just a to the x. Okay. Okay, let's take another one. I'm going to number these. Let's say that we have a squared times b to the negative 1 to the negative 1 over a to the negative 4th b. Okay, so this one is a little bit different. So a squared, so our goal is going to be the same. I'm sorry, I should have put this in black, but it doesn't matter so much. Our goal is going to be the same. We want to get rid of exponents first. So we see a negative 1 out here. The way that we get rid of the exponent is we distribute it. Okay, so we wind up with a to the negative 2, b to the positive 1. You don't have to write the 1. I'm writing the 1 here just so that you see that it's there. And now this is a to the negative 4, also b to the 1. Okay, so our first step here was the same. Get rid of parentheses. By distributing. Okay, that means you're multiplying exponents. Now if you see here, there's more than one of each base, right? There's an a in the numerator and an a in the denominator. So we're going to use that rule where if we have the same base and we're dividing, whoops, sorry about that. If we have the same base and we're dividing, here, we subtract the exponents. So that's what we're going to do. So -2 minus -4 is -2 plus 4, or a to the first. And then we get b to the 0. So our b's are actually just canceling out here. Okay, sorry, I'm going to put that in blue so that you see that it's the same problem. And what we did here is we just combined vertically. By subtracting exponents. And there are no negative exponents, so we're done here. Okay. Let's take another one similar to this. I encourage you, by the way, once you feel like you're starting to get the idea, when I write down the problem, pause it. Like I can't, this is not in class, so I'm not giving you time to do it by yourself. So the way to practice by yourself is pause it, do it on your own, and then press play again and see if you can follow along what we did and if you got the right answer. Okay, so instead of mine just giving you one on the board to try on your own, pause the video, try it on your own, and then see if you got it correct. Okay, so let's take the next example. So in this one, we have a to the 5th, b to the -4th, c squared, divided by a to the -4, b to the 8th, c to the 1st. You could see that these get a little bit more complicated as we go. And this is being raised to the -3rd power. So we're going to do the same thing here. We want to get rid of exponents first. So this is an exponent raised to an exponent, so we can just multiply. Okay, and notice everything here is being raised to the -3, whereas up here, only the top was being raised to the -1. So we have a to the -15, b to the +12, we're multiplying. Do not add and do not raise to an exponent. So don't do 2 to the -3. You're doing 2 times -3. Then we have a to the +12. It's positive because we have a -4 times a -3. B to the -24. And C to the -3. Okay, so we got rid of the parentheses by distributing the exponent. I'm going to stop writing a lot of this. So notice this is always our first step. So our second step is going to be to combine vertically. We only see one of each base in the numerator and one of each base in the denominator. This is going to change eventually. Okay, so, but we see an a in both the numerator and the denominator, which means that we have to combine vertically. When we combine vertically, we subtract the exponents. So -15 minus 12 is -27. 12 minus -24 is +36. And -6 minus -3 is -3. So here we combined vertically, which means subtract exponents. And then the final thing that we're going to do is get rid of these negative exponents here. And the way that we do that is we just move them to the denominator. So we have b to the 36 is positive. It stays where it is. A to the 27th goes to the bottom, and c to the 3rd also goes to the bottom. So this was our last step. Okay. And that would be our final answer. Let's take another one. A b squared over a cubed c. We're going to square this. Now this looks like it's going to be so much harder, but please, please, please be aware that it's not harder. It's just a little bit longer. This is an a over here. Then we have a to the 5th, b to the 3rd. Let's put a c in here. C to the -2 over a to the -6, b, c to the 5th, and we'll square this. Okay, it looks really long. This is not hard, okay? We're going to go through it in the same way that we did before. We're going to distribute the exponents. So this 2 gets distributed to everything in this set of parentheses. It only applies to this set of parentheses, and it's the whole set. So we wind up with a squared, b to the 4th. Be careful here, one mistake will follow you through. Then we have a to the 6th, b squared. Notice we're multiplying exponents. Now here, because we're getting rid of this and it's all multiplying, we can actually just do this all in one nice long thing. So I'm going to put a times here, but eventually what you're going to see is that a line is just going to go through it because it's one fraction. So then we have a to the 10th, b to the 6th, c to the -4th, over a to the -12th, b squared, c to the 10th. And because we're multiplying, we can just extend this line. Okay, now this is the difference here. In each of the other cases, our next step was to combine vertically. But here we see more than one base. In the numerator, we see 2 a's and 2 b's. So our next step is to combine horizontally. Okay, and again, I encourage you to do it in this order because if you combine vertically, how are you going to know which a's to subtract? Okay, right now they're above each other, but sometimes they're not, and you're going to ask yourself, well, do I combine the a squared and the a to the -12th? So you want to combine horizontally first. And when we combine horizontally, we add the exponents. So a squared and a to the 10th gives us a to the 12th. B to the 4th, b to the 6th gives us b to the 10th. And then we have c to the -4. And then 6 and -12 is -6. And b squared and b squared is b to the 4th. So we combined horizontally. So this was the step that we were missing, and now we're doing it. This is the greatest number of steps that we'll ever have to do. It's a 4-step process. So now we're going to combine vertically. Okay, So 12 minus -6. Another reason for combining vertically first is that you only have to subtract exponents once, which makes it so much nicer because subtracting positive and negative numbers is more of a pain. So let's try and fit this here. So 12 minus -6 is 18. So we have a to the 18th. 10 minus 4 is 6. And then -4 minus 10 is -14. And our last step is to get rid of those negative exponents. So the only negative exponent here is the 14. So the c to the -14 is going to go on bottom. So our final answer is a to the 18, b to the 6, over c to the 14. So we combine horizontally, then we combine vertically. This is our subtracting. And then we get rid of negative exponents. Let's take one or two more. Let's do one that's a little bit different. Let's put an actual number in here. Let's say that we have 2, a to the 5th, b to the -3, c squared, and this will get raised to the -2 power. Okay, and then let's do over a cubed, b, c to the 10th, and let's multiply this by a squared b to the 4th over a c to the -3. This is as hard as it will get. It will not get any harder than this. Okay? So we're going to do the same thing. We're going to get rid of our parentheses. So the parentheses over here, notice there are no exponents. It's just a way to differentiate between this fraction and this fraction. Because in this fraction, the top is being multiplied by -2. We actually didn't need the parentheses. Okay? It's just put in there just for clarity. Okay? So these parentheses can just get taken out. This one, we have to distribute the -2. So we have the 2 here, so be careful. So we're going to just keep it as 2 to the -2 right now. I'm actually going to make this a 3. I'll erase that and rewrite it. Okay, so 2 to the -3. Then we can just multiply exponents as usual. So we have a to the -15, b to the +9, c to the -6th, over a cubed, b, c to the 10th. This one can just get rewritten. We're just going to take out the exponents. It can just be rewritten as it is. It's not being raised to anything. There are no powers here on the outside. And again, we just extend the line. Okay, so what do we do with this 2 to the 3rd? This 2 to the -3, we're just going to move to the bottom and make it a positive power. Okay, and that's going to help here. So I'm just going to rewrite this because it does not look clear. Okay, that's a little better. So we're going to move the 2 to the negative 3 to the bottom, and that'll make it positive. And we're going to do two things at once. We're going to move the 2 to the negative 3 to the bottom, and we're going to combine horizontally. So negative 15 and 2 is negative 13. 9 and 4 is positive 13. And there's only one C. Then we have this 2 to the third. A to the third and A to the first gives us A to the fourth. Then we have B. And 10 and negative 3 is 7. Now we're going to combine vertically. Okay? So 2 to the third is 8. So notice we did not multiply 2 and 3. Okay? This is 2 being raised to a third power. 2 is not an exponent. When we multiply the 5 and the negative 3, that's because 5 is an exponent. 2 is not. So we raise it to the third. So this becomes 1 over 8. That comes from the 2 to the third. Negative 13 minus 4 is negative 17. 13 minus 1 is 12. And negative 6 minus 7 is negative 13. And now our last step is to get rid of the negative exponents. The a to the 17th can move to the bottom with the 8, and so can the c to the negative 13th. So we have b to the 12th. Then we have 8, a to the 17, c to the 13. Okay, so let's put in some notes here. So this part was just distributing. Okay. This came from 2 to the negative 3 is equal to 1 over 2 cubed. Okay. We also combined horizontally. This 1 to the 8th came from the 1 over 2 cubed. Okay, we just pulled it out to the side. And we also combined vertically. And then here we got rid of negative exponents. Okay. I'm going to do one last one, and I encourage you to pause the video, do it on your own, and then walk through it with me together. So our last one, I'm going to do it similar to this. Let's do 4 a cubed b to the negative 1 c squared. We'll raise this to the second over a to the 5th b. This is the hardest that it will ever get. Over 2 a to the 5th b cubed c to the negative 5. We'll raise this to the negative 2 over b cubed c squared. And we'll add in another one here. So again, this is the hardest that it's ever going to get. A to the negative 2 b to the 4th c squared over a. We'll add in a d here. B cubed c to the negative 2 d cubed, and we'll raise this to the negative 2 power. Okay? Absolute hardest. But it's still only a 4-step process. We're going to distribute our exponents, then we're going to combine horizontally, combine vertically, and get rid of negative exponents. So it's the same thing. Distribute, Then it's going to consist of adding exponents as we combine horizontally, subtracting exponents as we combine vertically, and then getting rid of negative exponents. It's just a little bit longer to do. So we're going to distribute this 2. That gives us a 4 squared. Don't multiply. These get multiplied. A to the 6th, b to the negative 2, c to the 4th. If you haven't paused this to try it on your own, please try it on your own. Pause it. A to the 5th b times 2 to the negative 2. You'll take care of that later. A to the negative 10, b to the negative 6, b to the negative 6, c to the positive 10. The bottom, nothing is happening to. That negative 2 on top only applies to the top. Okay? And now the last one. We distribute the exponent to everything. So it becomes a to the 4th, b to the negative 8, c to the negative 4, d to the negative 2, over a to the negative 2, b to the negative 6, c to the positive 4, and d to the negative 6. Okay, now we're going to do 2 things simultaneously. We're going to add across, we're going to combine horizontally, and we're going to move this 2 to the negative 2 down to the bottom. Okay, we'll leave the 4 squared for now. So I see an a to the 6th, an a to the negative 10, and an a to the 4th. 6 minus 10 is negative 4, minus another 4 is 8, is negative 8. So we have a to the negative 8. Did I do that right? 6 minus 10 is negative 4 plus 4. Sorry, a to the 0. I make mistakes too. Just take it slow. 6 minus 10 is negative 4 plus 4 is 0. So this is a to the 0. Okay, then we have our b. So negative 2 and negative 6 is negative 8, plus negative 8 is negative 16. Then we have our c. 4 and 10 is 14, minus 4 is 10. And then we have our d, and we only have one d over here, so it's just d to the negative 2. Now on bottom, don't forget the 2. So this is now 2 to the positive 2. We moved it to the bottom. We have an a to the 5th and an a to the negative 2. That gives us an a to the 3rd. Then we have a b to the 1st, a b to the 3rd, and a b to the negative 6. So 1 and 3 is 4, minus 6 is negative 2. Then we have a c squared and a c to the 4th. C squared and c to the 4th is c to the 6th. And then we have a d to the negative 6. Now we can combine vertically. So 4 squared is 16. We'll just write this as 16 over 4. So we could just put that off to the side for now. 0 minus 3 is a to the negative 3. Negative 16 minus negative 2 is negative 14. That's for the b. 10 minus 6 is 4. That's for the c. And negative 2 minus negative 6 is positive 4. Now we can get rid of negative exponents, and we're just going to simplify this. This is a 4. And it goes into the numerator. So the positive exponents here are c to the 4th and d to the 4th, so that remains on top. And the negative ones are a and b, so it becomes a to the positive 3, b to the positive 14. So let's just review what happened here. We distributed the exponents. the 2 to the negative 2 became 1 over 2 squared. Okay. So we combined horizontally here. Okay, we did that by adding the exponents. Then here we combined vertically. The 16 came from 4 squared. And the 4 came from 2 squared. Then we got rid of negative exponents. And that's it. These are all of the properties of exponents and how we simplify exponential expressions. For the next lecture, we're going to talk about radical expressions, which I've said to you multiple times is the same thing as an exponential expression. It works in the same way. Okay, that's it for now, and hopefully I'll post the next video very soon.